All right, this is cool. Before we get started, I just wanted to let you guys know that this is my 500th YouTube video. Woohoo! That's a lot of video uploading. So I just wanted to thank all of you for being faithful watchers of the channel. And for those of you who've had class with me, just know that I appreciate all your hard work over the years and years of doing math with me, with Dave Smith. And I just want to celebrate because this is kind of a milestone. 500 videos, that's actually been quite a bit of work. So I'm pleased and proud, and here's to the next 500. Today's lesson covers using regression lines to make predictions. Now remember, regression lines come from scatter plots. And scatter plots are just graphs of very specific points that come from our collected data. There are three conditions necessary to be able to do this. So let's go over those. First one, we need a strong correlation. This makes sense. If you don't have a strong correlation, then you shouldn't be using it to make predictions because your correlation is not very strong. So in this case, that would be R is greater than 0.75, less than 1. Now there's another condition very similar to this one that also applies. Pause the video and see if you can think of that one. So if you figured out that we can also have a negative correlation that can still be strong, you're right. So if our R value is between minus 0.75 and negative 1, it means we have a strong negative correlation, and that also can be used to make predictions. The next one is we're predicting Y given X. We're not predicting it the other way around. So watch out. There are tricky questions out there where they'll give you a Y and ask you to use your correlation to predict X, and strictly speaking, not allowed. Okay, here's our third condition. The prediction must be interpolation, yes, but not extrapolation. Now those are both two big $10 words. It's going to make sense in a minute. I'm going to show you the definition and we'll look at it on the graph. So check this out. A prediction must be within the range of the data set. So let's make a prediction. What if X equals 7, and here's my scatter plot. You see all my points, and I sketched in a best fit line on that scatter plot. If X is 7, let's put a little if, then what would Y be? And we can zip along our line and go 7 is there. Here, I'm going to use a different color. I'm going to use green because this one's okay. There's 7. We go up, we cut across, and maybe Y would be 4. Okay, nice. So what I want you to do is pause the video and do two more for me. Do if X equals 15, and then if X equals 25. Okay, and so pause the video and use your graph on your note paper to predict what Y would be for these two values of X, and then come back. Okay, let's see how you did. So the first one, if X is 15, I start here with my X on my X-axis, I go up, straight up to my line, cut across, and I get a Y value of 12. And you notice I put that in green because that indeed is okay. But check this out. When we do X is 25, we come up here, we hit our line, and we go across and we get 19. But that's not okay. That is extrapolation because we're not within the range of our data set. Our data set goes all the way to here, which is maybe an X value of 20. We're predicting if X is 25, and we really don't have any data out there to support that prediction or that interpolation. It's extrapolation. So we can't do that. And here's the reason. We don't know what the data does here. What if the data takes a curve like this and flattens out? Like height versus age. Like in your childhood years and your teen years, your height curve is going to keep increasing. But once you hit your max height, maybe 17, maybe 20, it's going to be a flat line. So if I used your height curve from age 0 to age 15 to predict what your height would be at age 30, probably be something like 10 or 12 feet. And obviously that would be wrong. So that would be extrapolation, and you can't do that. So watch out for that in some of the problems. All right, here is a scenario. Got some data. We took 12 people, and we figured out what their height was in centimeters. That's our X value. And then we figured out what their shoe size was. This is the European shoe size, and that's the Y value. Okay, so here's our question. One of our pals has a height of 163 centimeters, and we want to predict what shoe size they would have. So first, before we do that, we need to find out if this is a sensical situation, if that meets our 3 conditions from the last boards there. So first one, are we predicting Y based on X? Yes. We're given a height, and we're asked to predict the shoe size. So yes, that's good. Second one, do we have a strong correlation? We're going to do that in a minute. We're going to put this in the calculator. We're going to figure out what our R is, and that'll be our final yes or no for what we can do here. The third one is it interpolation or extrapolation? In other words, is this height within our range of heights? And you can see right clearly that it is, because 160 is a low height. This is higher than that. And then we have plenty of heights that are higher than 163. So yes, we're not doing extrapolation, we're doing interpolation. So now what you need to do is pull up your calculator, and we're going to get the full gamut on this. We need to find our R value, and we need to find our A value, that is our slope, and we need to find our B value, that's our intercept, because we're going to need the full equation to make our prediction. So go ahead and find your R, your A, and your B. Put this data in your calculator and go for it. All right, let's see how you did. I got 0.8454 for my R value, strong positive correlation, so definitely helps us qualify this situation for making our prediction. So we're good to go. We've satisfied all 3 of those conditions. My A is not 1.54, but 0.54. So the A value is 0.54. And then finally my B value is 12. So now I want you to use this information to write the equation of the best fit line. So pause the video, do that, and come right back. All right, pretty straightforward. The A value, that's our multiplier on X. That's the slope of our regression line. And the B value is the Y-intercept, or the value when X is 0. So here's my equation, 0.1554X plus 12. Now what I want you to do is pause the video and answer the question. What shoe size is a 163 centimeter tall person likely to have? All right, so I did my plug-in step here, did my math, I got 37.1 for my shoe size. Now, we know there is no 37.1. So with shoe size, you're most likely just gonna round up, because if you're a little bit bigger than a 37, it doesn't matter how much bigger, you're gonna need the next size up. But in this case, 0.1, not that much more. So if I were trying on shoes, I'd probably try the 37 first, but I'd be ready to go to the 38. So that might be a critical thinking part of this question, should you see it on a quiz or on a test. All right, for practice, let's do 2 more predictions. I'm just going to put them both up here, and then I want you to pause the video and do those predictions, see what you get, and come back and we'll go over that. So this one is, what is the shoe size for a 150 centimeter tall person? So go ahead, plug that into your equation, find out that shoe size, and come back. Second question is, let's say we have a person that has a shoe size of 38. Let's use our shoe size to predict the height that that person might have. Okay, so pause the video, come right back, and let's take a look at how you did. All right, I hope you caught that. Both of these predictions cannot be made based on the data set. So hopefully you caught that and you didn't do all that math. If you did the math, it's good practice, but you want to watch out for this. So the first one, this is extrapolation. 150 centimeters is not in the range of our data. So we can't use it to predict a shoe size if it's not in the range of our data. So this one is, you can't do it due to extrapolation. It's not interpolation, which is what we want to use. This one, we are predicting X based on Y. So we're going the other way. We're not starting with height and predicting shoe size. We're starting with shoe size and predicting height. And we can't do it that way. We made our whole equation based on these numbers being x and these numbers being y. So this prediction cannot be made either. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.